For years, the conversation around artificial intelligence has centered on one question: who can build the fastest AI chip? The assumption has been that challenging NVIDIA simply means creating a processor with more computing power, higher memory bandwidth, or better benchmark scores. But the AI industry has evolved beyond that point. Today, the companies setting the direction of the market are no longer competing with individual chips alone. They are competing with entire computing ecosystems. That is what makes Alibaba's latest announcement worth examining. Alongside its new Zhuanwu M890 AI accelerator, the company introduced a dedicated networking processor, a proprietary software platform, and a rack-scale system capable of integrating 128 AI accelerators into a single computing unit. These components are designed to work alongside Alibaba Cloud and the company's growing family of Qwen AI models, creating an infrastructure where hardware, software, networking, and cloud services are developed as one coordinated platform. This strategy closely mirrors the approach that helped NVIDIA establish its leadership in AI. The real advantage was never just faster silicon. It was the ability to combine processors, networking, software tools, and developer support into one tightly integrated ecosystem that customers could rely on from end to end. The question now is whether Alibaba can build a similar advantage within China. If enterprises begin adopting an ecosystem optimized entirely around domestic hardware and cloud infrastructure, the competition may shift away from comparing individual chips. Instead, success could depend on which company delivers the most complete AI platform, one that allows businesses to develop, deploy, and scale artificial intelligence with fewer dependencies on external technology. At the center of Alibaba's new AI strategy is the Zhuanwu M890, an accelerator developed by the company's semiconductor subsidiary, T-Head. Alibaba describes it as a major step forward from its previous generation, reporting roughly 3 times the performance of the earlier Zhuanwu 810 series. That comparison is worth noting because it measures progress within Alibaba's own product lineup, rather than against NVIDIA's latest H100, H200, or Blackwell accelerators. At this stage, there are still too few independently verified benchmarks to determine exactly where the M890 stands in the global AI hardware market. Even so, the processor's specifications reveal what Alibaba is trying to accomplish. The M890 includes 194 gigabytes of onboard memory and supports multiple numerical precision formats ranging from FP32 down to FP4. This flexibility allows developers to balance computational accuracy with efficiency. Higher precision formats remain important for workloads where numerical stability is essential, while lower precision operations can significantly accelerate inference and reduce computing costs for many AI applications. Another notable feature is the chip's 800 gigabytes per second of interchip communication bandwidth. Although processor performance often receives the most attention, moving information between accelerators has become equally important as AI models continue expanding. Large models frequently distribute calculations across multiple chips, meaning communication speed can directly influence overall system performance. These design choices suggest that Alibaba is optimizing the M890 for a new generation of AI applications known as AI agents. Unlike traditional chatbots that simply generate responses to prompts, AI agents perform sequences of connected tasks. They may retrieve information from databases, interact with external software tools, coordinate with other AI systems, maintain long-term context, and execute workflows that continue for extended periods without human intervention. Supporting these workloads requires more than raw computational power. AI agents continuously exchange large volumes of intermediate data while maintaining extensive working memory throughout each task. If processors cannot communicate efficiently, much of their theoretical performance remains unused as they wait for information to arrive. The M890's architecture reflects Alibaba's recognition that future AI infrastructure will depend not only on faster computation, but also on faster coordination between processors. Rather than designing a chip solely to maximize benchmark scores, the company appears focused on creating hardware that performs efficiently within large, interconnected AI systems. While the M890 serves as the foundation of Alibaba's new AI platform, the company clearly recognizes that modern artificial intelligence is no longer powered by individual processors working in isolation. Today's largest AI models are simply too large and too complex to fit inside a single accelerator. Instead, they rely on hundreds or even thousands of processors operating together as one coordinated computing system. That reality explains why Alibaba's biggest announcement may not have been the chip itself, but the infrastructure built around it. At the heart of that infrastructure is the Pangu AL128, a rack-scale AI system that integrates 128 M890 accelerators into a single computing platform. Rather than emphasizing the performance of one processor, Alibaba designed the system to maximize the efficiency of the entire cluster. According to the company, the platform delivers internal communication bandwidth on the petabyte per second scale, allowing enormous volumes of data to move rapidly between processors. It is important to understand what the figure represents. It does not mean a single M890 chip transfers data at petabyte per second speeds. Instead, it reflects the combined communication capacity of the entire rack, where dozens of accelerators exchange information simultaneously. As AI workloads become increasingly distributed, this internal communication has become just as critical as the computing power of the processors themselves. To support that architecture, Alibaba also introduced a dedicated networking processor known as ICN Switch 1.0. The company says the networking chip provides up to 25.6 terabits per second of aggregate switching bandwidth, while supporting full bandwidth connections across groups of AI accelerators. Its role is straightforward but essential, ensuring that processors can exchange data quickly enough to remain productive throughout large-scale AI workloads. This addresses one of the most persistent challenges in modern computing. During AI training and inference, processors constantly exchange model parameters, activation values, and intermediate results. If communication slows, even the fastest accelerator eventually reaches a point where it has nothing to compute because it is waiting for information from neighboring chips. Every delay reduces hardware utilization and increases the overall time required to complete a workload. Alibaba's rack-scale strategy is designed to minimize those interruptions. By tightly integrating processors with a high-capacity communication network, the company aims to keep data flowing continuously across the system. The objective is not simply to make individual chips faster, but to ensure that all 128 accelerators operate efficiently as a unified machine rather than a collection of separate devices. This reflects a broader shift occurring throughout the AI industry. Competitive advantage is increasingly determined by system architecture, not processor specifications alone. As AI models continue expanding, the companies capable of coordinating thousands of accelerators with minimal communication overhead are likely to extract far greater real-world performance than those focused only on increasing the speed of individual chips. Alibaba's Pangu AL128 demonstrates that the future of AI infrastructure may depend as much on how processors work together as on how powerful each processor is individually. Powerful hardware alone has never been enough to dominate the AI industry. If that were the case, new competitors would have displaced NVIDIA years ago. Instead, NVIDIA's strongest advantage has been the ecosystem surrounding its processors. Over more than a decade, the company built CUDA into the standard software platform for AI development, giving researchers and enterprises an environment where applications, tools, and optimized libraries already work together. For developers, this ecosystem is often more valuable than the processor itself. AI models are trained using software frameworks that have been refined for years around CUDA. Machine learning libraries, optimization tools, debugging utilities, and deployment platforms have all evolved with NVIDIA hardware in mind. As a result, organizations purchasing NVIDIA accelerators are not simply buying computing power. They are investing in an established development environment supported by millions of engineers worldwide. That creates a significant barrier for any competitor. Even if another company produces hardware with comparable specifications, customers must consider the cost of migrating existing software, retraining engineering teams, validating AI models, and rebuilding production workflows. Those switching costs can be substantial, making software compatibility just as important as hardware performance. Alibaba appears to understand this challenge. Rather than positioning the M890 as a standalone accelerator, the company is building an ecosystem where every major component is designed to reinforce the others. Its proprietary software platform provides the tools needed to optimize workloads for its hardware, while Alibaba Cloud supplies the infrastructure for deployment. At the application layer, the company's Qwen family of large language models is being developed alongside the hardware, allowing software and silicon to evolve together instead of independently. This level of vertical integration offers several strategic advantages. Engineers designing AI models can optimize them specifically for the capabilities of the M890, while chip designers can incorporate features that better support workloads already running inside Alibaba Cloud. Improvements made in one part of the platform can benefit the rest of the ecosystem without waiting for third-party vendors to adapt. Over time, this creates a feedback loop where hardware, software, and cloud services improve together. Importantly, Alibaba does not necessarily need to persuade every AI developer in the world to abandon NVIDIA. Its immediate opportunity lies within its own cloud ecosystem. Thousands of businesses already rely on Alibaba Cloud for computing resources, data storage, and enterprise applications. If those customers can deploy AI models efficiently using Alibaba's integrated platform, many may see little reason to depend on external hardware for domestic workloads. This strategy mirrors a broader trend emerging across the AI industry. Companies are increasingly competing through complete computing platforms rather than isolated products. Processors, networking, software frameworks, cloud infrastructure, and AI models are becoming tightly connected pieces of a single system. In that environment, long-term success may depend less on producing the fastest chip and more on delivering the most seamless development experience. That is the competition Alibaba appears to be entering. Not simply a race for benchmark scores, but a race to build an ecosystem capable of supporting every stage of artificial intelligence, from model development to large-scale deployment. Alibaba's decision to invest heavily in its own AI hardware is not happening in isolation. It reflects a broader shift that has taken place across China's technology industry over the past several years. As U.S. export controls on advanced AI processors became more restrictive, Chinese cloud providers found themselves facing an increasingly uncertain supply of the hardware they had relied on to expand their AI services. For companies operating massive cloud platforms, that uncertainty creates a long-term business risk. Building an AI data center is a multi-year investment involving billions of dollars in infrastructure, power systems, networking equipment, and software development. Those investments are difficult to justify if access to critical processors can change because of future policy decisions. Even temporary disruptions in hardware availability can delay expansion plans and complicate capacity planning for enterprise customers. This does not mean Alibaba has stopped valuing NVIDIA's technology. NVIDIA's accelerators remain among the most capable AI processors available, and demand for them continues to be strong wherever they can legally be deployed. However, relying on a single foreign supplier has become increasingly difficult from a strategic perspective. A cloud provider cannot build its entire AI roadmap around hardware whose long-term availability remains uncertain. Developing domestic alternatives offers Alibaba another path forward. Even if locally designed processors initially trail the world's leading accelerators in certain benchmarks, they provide something equally important: greater control over the supply chain. By designing its own silicon, integrating it into its own cloud infrastructure, and supporting it with proprietary software, Alibaba can reduce its dependence on external technology while planning future expansion with greater confidence. This strategy also extends beyond hardware performance. When a company controls the processor, networking architecture, software stack, and cloud platform, it gains much greater flexibility to optimize the entire system. Product schedules become less dependent on outside vendors. Software can be tailored specifically for in-house hardware, and infrastructure investments can follow a more predictable roadmap. That level of control becomes especially valuable in an environment where geopolitical uncertainty increasingly influences technology markets. The result is a broader transformation in China's AI industry. Rather than viewing domestic chips as temporary substitutes, companies like Alibaba are beginning to treat them as long-term strategic assets. The objective is not simply to replace imported hardware whenever restrictions appear. It is to build an AI ecosystem that can continue evolving regardless of external supply constraints. In that sense, the M890 represents more than a new processor. It reflects a wider effort to create a more self-sufficient foundation for China's next generation of cloud computing and artificial intelligence. New AI hardware announcements often focus on technical specifications, but long-term success is determined by something far more practical: adoption. A processor may offer impressive performance on paper, yet its real impact depends on how many customers deploy it, how reliably it operates in production, and whether it becomes part of everyday AI infrastructure. For Alibaba, these factors are now just as important as the capabilities of the M890 itself. Alibaba has stated that its AI hardware is already being integrated across Alibaba Cloud, where it supports a growing range of artificial intelligence services. Unlike a startup introducing a completely new platform, Alibaba begins with an existing cloud ecosystem that already serves millions of businesses. This gives the company an immediate opportunity to deploy its own processors internally before expanding availability to outside customers. That strategy provides several advantages. Operating its hardware inside its own cloud allows Alibaba to identify software bottlenecks, improve system stability, and optimize performance under real production workloads. Instead of relying solely on laboratory benchmarks, engineers can continuously refine both the hardware and software using feedback from large-scale commercial deployments. This iterative approach often produces more meaningful improvements than isolated performance demonstrations. At the same time, reported deployment figures should be interpreted carefully. Companies frequently announce cumulative shipments, installed systems, or infrastructure investments, but those numbers do not necessarily indicate how many next-generation processors have entered active service. They may include previous hardware generations, internal deployments, pilot projects, or systems reserved for future expansion. Understanding these distinctions is essential when evaluating the maturity of any AI platform. Another useful indicator is customer adoption. Large enterprises rarely migrate critical AI workloads overnight. Before committing to a new hardware platform, organizations typically evaluate software compatibility, operational reliability, technical support, and long-term product roadmaps. Even if a processor delivers competitive performance, enterprise customers often require months of testing before deploying it across production environments. Alibaba's position as one of China's largest cloud providers may help accelerate that process. Many existing customers already depend on Alibaba Cloud for storage, computing, databases, and enterprise services. If AI accelerators become another integrated service within that ecosystem, businesses may find it easier to adopt domestic AI hardware without redesigning their broader technology infrastructure. Still, it is important to distinguish growing market presence from market leadership. Alibaba has clearly established itself as a serious participant in China's AI infrastructure landscape, but the competitive environment remains dynamic. Domestic rivals continue investing heavily in AI accelerators, while global leaders maintain significant advantages in software ecosystems and developer adoption. The coming years will reveal whether Alibaba's integrated platform can translate steady deployment into sustained competitive momentum, or whether the AI market will remain shared among multiple hardware ecosystems rather than dominated by a single provider. As China's AI industry expands, Alibaba is not pursuing its ambitions alone. One of its most significant domestic competitors is Huawei, a company that has spent years building its own AI hardware ecosystem through the Ascend series of processors. Although both companies share the broader objective of strengthening China's AI infrastructure, their strategies differ in important ways. Huawei's approach is rooted in its long history of telecommunications equipment, enterprise computing, and semiconductor design. Its AI accelerators are part of a broader portfolio that includes networking hardware, cloud services, operating systems, and enterprise solutions. This allows Huawei to offer integrated computing platforms for industries ranging from telecommunications and manufacturing to government and scientific research. Alibaba, by contrast, is approaching the market from the perspective of a cloud service provider. Its greatest strength is not telecommunications infrastructure, but one of China's largest cloud computing ecosystems. Instead of focusing primarily on selling hardware, Alibaba is developing processors that enhance the services already delivered through Alibaba Cloud. The company's AI models, cloud platform, software stack, and computing infrastructure are all being designed to complement one another, creating an environment where customers can build and deploy AI applications within a single ecosystem. These different starting points shape the kinds of customers each company is likely to attract. Organizations already invested in Alibaba Cloud may naturally prefer hardware that integrates seamlessly with existing cloud services and AI development tools. Meanwhile, enterprises with long-standing relationships in Huawei's networking and enterprise technology ecosystem may find Huawei's solutions more aligned with their infrastructure. Rather than producing a single dominant platform, this competition could accelerate innovation across China's AI industry. Both companies are investing heavily in processors, networking technologies, software optimization, and cloud infrastructure. As they compete to improve performance, reduce costs, and simplify deployment, customers may ultimately benefit from faster technological progress and a broader range of domestic AI solutions. However, multiple ecosystems also introduce new challenges. Software developers may need to support different programming environments, optimization tools, and deployment frameworks depending on the hardware being used. Unlike NVIDIA's CUDA ecosystem, which has become a widely adopted industry standard, China's domestic AI market could evolve into several competing software platforms. That fragmentation may increase development complexity until broader standards emerge. Ultimately, the competition between Alibaba and Huawei is not simply about benchmark performance or chip specifications. It represents two distinct visions for achieving greater technological independence. One builds on cloud computing and AI services, while the other leverages decades of experience in communications and enterprise infrastructure. Both approaches are likely to play an important role as China continues developing a more self-reliant AI ecosystem. And their rivalry may prove just as influential as competition with international hardware providers.